Hey guys! Welcome back to my YouTube channel. So for this week, I'm going to explain to you how you should answer the test 1 question, which consists of chapter 1 until chapter 3. So altogether we have 6 different questions from this chapter, and let's get started. We are going to start with question number 1. Oxygen is pumped into a tank to supply breathing air for scuba diving until the gas pressure reaches 4.05 atm. Helium is then pumped until the total pressure is 20 atm. The gases are allowed to mix completely. The tank is then used until the total pressure of gas is 9.5 atm. Determine the partial pressure of each gas in the tank. So how are you going to tackle this question? So from this question, we know that we have 2 different types of gases, which is oxygen and helium. So they are being mixed together. So they must be the total pressure. So the total pressure is equivalent to pressure of oxygen plus pressure of helium. Right. And then you read again the question. It states that oxygen is pumped into a tank, and then until the gas pressure is 4.05. So the pressure for oxygen is 4.05. So what is the pressure for helium? And then it states here that helium is pumped until the total pressure is 20 atm. So the total pressure here is equivalent to 20 atm. So here we can put X, right? So we can say that pressure of helium, which is X, is equivalent to 20 minus 4.05 atm. So you should get the pressure for helium is equivalent to 15.95 atm. Right. So this is the first part. And then you need to find the mole fraction. So what is the mole fraction of the gas? So in terms of calculating the mole fraction, so you need to know that the mole fraction is equivalent to the pressure of the gas that you want to know the mole fraction. For example, this one, I want to calculate for oxygen first, divided by the total pressure. So the total pressure we know from the question is 20. So mole fraction of oxygen. So the pressure of oxygen given in the question also is 4.05. So 4.05 divided by 20, you should get the mole fraction for oxygen equivalent to 0.2025. So this is the mole fraction. And then you should calculate the mole fraction for helium also. So mole fraction for helium is the same thing, which is the pressure for helium divided by 20, which is the total pressure. And then the pressure for helium is this one, the one we have calculated just now, 15.95 divided by 20. So you should get the mole fraction for helium is equivalent to 0.7975. Okay, so this is a mole fraction. And then given in the question, it states that the tank is then used until the total pressure of the gas is actually 9.5 atm. So the new total pressure is equivalent to 9.5 atm. Okay, now you were asked to find what is the partial pressure of each gas. So you want to know what is the partial pressure of each gas, means that the partial pressure should be equivalent to mole fraction times total pressure. So you already know the mole fraction of each gas. So we are going to calculate for oxygen first. So we are going to use this mole fraction. So partial pressure for oxygen is equivalent to, the mole fraction is 0.2025 times the total pressure, the new total pressure, because it have been used. New total pressure is 9.5 times 9.5. You should get the partial pressure for oxygen is equivalent to 1.9238 atm. Okay, and then you're going to do the same drill. So partial pressure now for helium, right? So equivalent to the mole fraction for helium. So the mole fraction of helium is this value, which is 0.7975 times the total pressure. The new total pressure is 9.5. Therefore, you should get the partial pressure for helium equivalent to 7.5763 atm. Right, so when you got all this correct, the total marks that you will get is actually 10 marks. Moving on to question number 1b. If 10 liters of oxygen at STP are heated to 512 degrees Celsius, estimate the new volume of oxygen gas should the pressure increases to 152 torr. Alright, this is a very straightforward question. You know, given to you is at STP. So STP, standard temperature pressure, means that the pressure is equivalent to 1 atm and the temperature is 273 Kelvin. Right? Okay, and then what else is given to you? See, heated to, and then it is being heated to, so your T2 heated to 512 degrees Celsius, right? But you know, because this one given to you is in STP, so you need to plus 273 so that you can change or convert this into Kelvin instead of degrees Celsius. So you should get 512 plus 273 is equivalent. The summation of this, you should get 785 Kelvin. Okay, what else that you need to know is you need to convert this 152 torr. You need to convert to atm because given to you is in STP. So you need to show how you're going to convert 152 torr into atm. So you just have to do 1 over 760 times 152. So you should get 0.2 atm. Okay, that's the first part of the calculation. Okay, next, what do you need to do? So you need to use the combined gas law formula. So P1 V1 over T1 is equivalent to P2 V2 over T2. Okay, so all of the values is being given in the question actually. So it's just initially it's at STP, right? So 1 atm, and then states here is 10 liter, so 10. Initial is at STP, so 273 is equivalent to the pressure. Here is 0.2. Volume is the one that you want to calculate, and the temperature is 785. Right. So from here you shall get this one. The V2 should be equivalent to 28.731 divided by 0.2, so you should get 143.6550 liter. Okay, and then again you need to read. Okay, estimate the new volume. Okay, you have already estimated, but look at the marks, it's 5 marks, so you need to have some elaboration. So how are you going to elaborate this? So it means that you need to make a statement saying that when the gas is being heated, the kinetic energy of the gas shall increase, hence making the pressure of the gas increases as well. Therefore, to regulate the pressure at 180 m, the gas shall move the movable piston to decrease the pressure. That is why at first the volume is actually 10 liter, but because the pressure is so high, therefore the volume needs to be bigger so that it can maintain the pressure to the pressure, the initial pressure. So this is the end of question 1.